So I'm doing title-driven talks here. I made up the title and then I made a talk for it. So we'll see how true it is. I've been a web developer mostly for 17 years now. I'm currently a freelancer at the Mäklarsamfundet, who has a really nice but old app that they've built on for about 4 years, I think, which is like their own custom kind of REST on the back end and the Angular one. So I'm currently there doing some GraphQL and React stuff because that's what we do now. So, how many here are familiar with GraphQL? Hey, maybe that's why you're here. Although the RX hands were quite a lot as well. So I'm gonna run through a bit of an introduction to GraphQL and the concepts. About as little as I can get away with to get on with the actual theme of the talk. So the first thing you need when making a GraphQL API are types. Although Facebook kind of wouldn't agree, they do have types in their hack language, and they generate the schema from their code. But we're going to do it the other way around here. We're going to make a schema, and then we're going to make an API. So the schema looks like this. You have your basic types, scalar types, which are like ints, strings, etc. And then you can make your own types, like post here is an object that can contain basically any combination of other types. And also posts can contain authors, and authors can contain an array of posts. The next thing you need are resolvers. Because now you have defined your types. The system knows how the result should look, but it doesn't know how to actually find the data. And that's the whole job of a resolver. So the basic resolver structure is this. You have your query object, and the query type is one of the few types that you get for free with GraphQL. And in it you put your public API basically, like anything you want to be able to get. And then for each type you can specify, or you only need to specify the non-basic, non-scalar types in here. How do we go about finding those? So author is going to contain an ID, a name, and that will just map from the data we get to the type, and it will all work. But when we get an author, that table isn't going to contain the posts. That's going to be somewhere else. So we tell the resolver, like, when you see posts, go here and find them. Any resolver gets 4 incoming arguments. So the first one is an object. It used to be called root, but now it's usually named object. It's the parent of the thing we're currently resolving. So on the top level, when you go and get posts, it's going to be the root query. And you are never going to need anything from there. But when we're trying to resolve authors in a post, the object is going to contain all the info about the post. Most importantly, the ID of the post and the author ID of the post, which we can then use to go and get the author. The next argument is args, which is reserved for actual incoming arguments in your GraphQL query. So when you make queries, you can add what you want. You can add like the ID of a user, and then that's going to be passed in here. Then we have context for like any custom shared state that I want to put there. I'm going to put like session data in here later. And then we have info, which used to be called fields, but they changed that too. And that's basically the internal query execution data. It's like everything that GraphQL knows about where we are in the current query. Usually we're not going to want anything from there, but I have one example where I actually go into that object, because that is where the cache control that I add is going to be fetched from. So this is going to be a JavaScript talk. I hope that it's the right audience for that. Otherwise, the last person was screwed. But we're going to be using GraphQL tools. And this is basically a way for us to write GraphQL syntax, which is language agnostic. It can be used for GraphQL servers in any language. But it will help us get it into a JavaScript definition. And actually writing GraphQL syntax, I think, is the way to go. When we saw early examples of GraphQL, it was almost always Facebook's first implementation of it, where you had a lot of weird JavaScript objects you had to import. But now we can write actual GraphQL. We're going to use Apollo Server, which is also, it's not completely language agnostic, but they have Apollo Server variants for most popular languages. And then we're going to use Express, which is our little JavaScript favorite. So the basic setup looks like this. Models is basically doesn't really have much to do with GraphQL. It will be the way we get stuff from the database. Make executable schema is the magic of the GraphQL tools library. It lets us it generates the code that you would have to write for the JavaScript implementation, but from GraphQL syntax. And we pass in the resolvers that we haven't written yet, but you're going to see soon. So this talk is not about authentication. There are different opinions. Basically anything that has to do with GraphQL, there are going to be vastly different opinions on. Because unlike REST that we've been doing for 10 years, the best practices haven't really settled yet. But I say keep authentication out of GraphQL. Just basically see if someone is logged in and should have access to the system, and otherwise throw them out before we get to the GraphQL part. Then this graphical thing isn't really needed for GraphQL, but it's basically the main developer tool for testing out your queries, building queries, making sure your resolvers work as you work on them. And it's a nice graphical interface for writing queries. But this is the actual GraphQL setup. We pass in the schema that we made, and we pass in the session data as context, so that we can access it to know who the user is, what roles he has, all of the stuff that we have in any authorization system, but is outside of GraphQL. So authentication in GraphQL is really not related to GraphQL. Just figure it out. Read the first tutorial for how to do authentication. Permissions or authorization, on the other hand, is more interesting. This part is super easy in REST because we have, maybe I said too much, but it is super easy in REST because you have a path for each thing that you want to get. It's really easy to figure out who should have access to what. But a GraphQL query can basically try to access anything. Like you start with getting users, but then you can get the users' posts, and then you can get comments, and then you can get the people behind the comments, and then you can try to get the personal details of the people behind the comments. And you're not allowed to do that because that's private data. And that's why permissions is kind of a fun subject. There are basically, at least for JavaScript implementations, there are basically two major ways to do this. You can either go the Apollo engine route. So Apollo is, except for Facebook, they are like the lead contributor to anything that has to do with GraphQL. For those not familiar with Apollo, they are Meteor.js, but they realized that Meteor is kind of dead. But Apollo and the GraphQL is really interesting, so that's kind of what they're focusing on. Or you can roll your own solution, which is going to be what this talk is about. If you really hate doing that, talk to the Apollo team, have their salespeople sell you their stuff. It costs money. You're going to have to do everything their way, basically. But it may be worth doing, unless you really like architecting solutions and making another solution 6 months from now. So our permission system is basically going to be create, read, update, delete instructions for each role and each type in the field. But it's not as bad as it sounds because we're going to make defaults that is gonna apply to almost everything, and then we're gonna just specify the exceptions. Mäklarsamfundet has about 300 different tables, which means 300 different entities. They have 5 roles that they are actively using, and some roles that we don't know what they do. Or at least I haven't been able to figure it out. So apart from specifying what a user should be allowed to do, we're going to have a pre-query step. That's basically, as we are trying to resolve the data, we are going to add user IDs, group IDs, to the query, so that already in this step we don't overfetch data. And then we're going to have a post-query step, because some things, like you can specify that this field you need a special permission from, and we're gonna select star on everything because that makes caching easier. If we cache all the data, but only deliver the data that the user has access to. We can use the same cache for multiple people. So these are the roles that I've generalized a bit, but basically it's super admin, admin, owner, which is a special one, like is it the person who made this content? There's also organization member, like do several people belong to the same group? And that's a common thing, that people in the same group should be able to see the same things. And anyone for open data. So the rules are basically going to be like this. So for each entity, you specify who can read, who can write, who can delete, who can update. And you do it on like a lowest role that is allowed to do this basis. So if an org member can do something, it also means that the owner can do it, an admin can do it, and a super admin can do it. But for some reason, only the super admin can see how many reads each post has. But we're not going to specify that for everything. We're going to apply these defaults, which means we can only specify the things that are different. Once we've specified our permissions, we simply add them to the context so that we can write some generic resolver factories, basically, that can take in all of this data and do clever stuff. We can write resolvers with permissions, basically. And I hope that I'm going to step through the code, and I hope that people will be able to read it. Otherwise, we can maybe take turns in standing up, like one row at a time. So basically, we make a resolver factory, and we're going to use this for like specifying the resolver for each type. We're going to use this factory and pass in the table name and the entity name. So everything else is like generic functionality, but it needs to know where to find the data and what GraphQL calls the data. And then it returns like a basic resolver. Whoops, that's the wrong button. Yeah, so we return a resolver that knows which entity and which table we're talking about. And for each, we're gonna use like a basic query builder and just build the query. I unabstracted this a bit so that we can put it in a presentation. So here's basically take a table name, start building a query, look only for undeleted stuff because that makes sense. And pull in the data we need from the context, which is the session data, which basically we only care about user ID and which groups the user belong to. And also get the permissions from the context, which is what we specified before. So here it will go and get the permissions that are about this entity name. So if we're resolving a post, it's gonna get the permissions for a post. So apply arguments, which is basically take the query, and if there are any arguments, add query params to it. And do the same for permissions. Like, if only an owner is allowed to see this, add the user ID to the query. And then you use your basic database call to get the data. And then we apply the post permissions that just checks which field does the user have the right to see, and filter it out. And applying the permissions looks a little something like this. It's also been unabstracted and generalized a bit. So for each table and each entity, we have a little, basically a list of the fields in this table. And because they don't have they've been building this system for a long time, so it's not like it's called user ID everywhere. There are maybe 6 different names that can contain like a reference to a user, depending on which table it is. So there's a little function for like going through the fields in a table and finding the name that is basically user ID. And same for organization, that can have a few different names. So those are basic helper functions. And a lot of tables, of course, are kind of general. They don't have an owner because they are just basic information. And then these are going to find nothing. Then you do a basic permission check. Like, we're only interested about the read permission here because it's a read query. So we just pass in the permissions and we pass in the roles that we got from session. And it's just going to check if it's higher or lower than the minimum role. And if it's clear that this user has access, we don't need to do anything else. But if it's not and the read permission says owner, we add like user ID to the query. And the same for organization member. We add, well, owner still has permission, but we also add the organization ID to the query. And in this case, the user can have multiple organizations, so we add like an in query. So that's basic permissions. It's just logic, nothing really special, not a library, very un-JavaScript-like. Just any questions about that before we move on to caching? Yes?
So when you apply the permissions, does the system take out the data that you don't have access to, or does it return errors or exceptions?
It only takes out data. For querying, I don't add any errors. For querying, I only add, they only get the data that they have access to, and that's it, basically. Which means that queries can get an empty object or empty array, which I think is fine. Because at least the way we've done it, the queries will be personal. Like, you ask for, this is a realtor app, so it's going to have like deals, estates. So if you ask for estates, you're going to get the ones that you have access to. And if you don't have access to any, you're going to get an empty array, and you're going to get an empty view in your in the app. You're going to see, here's a list of all your estates, you have none. For mutations, like changing data, we pass an error. Yes?
So how does your schema look then? Is every field nullable?
Yes, basically. Not every field, but almost every field. Like the ID fields are not nullable. But yeah, that's something that I find is kind of easy to take care of in the presentation layer. I would rather get null for something I don't have access to than an error. Or in the case of a list, you get an empty list, you don't get null. Okay, caching. I'm going to try to run through this a little more quickly. So, like I said, Apollo does everything GraphQL. And they have it's basically a specification for how to specify caching rules. And it's really simple. It's like, this is what you would come up with yourself, but they are trying to standardize things a bit so that we don't all come up with different things. So you can basically set max age on stuff, and you can set private or public on stuff. And if you set private on something, that just means that we're not going to cache this. This would only apply for one user and not all users. Data loader. Facebook says this is not a caching tool. It can be. We have chosen to only apply caching to subqueries, which means that when you get a top-level thing, like if I get, in our example, if I try to get all the posts, we're always going to run the post query. And we're going to get all of the posts that you have access to. But then, when things start to get a little hairy, when we try to get the authors from posts, the comments from posts, the authors to the comments, etc., etc., all of that is going to check the cache before returning something. And we chose to do it that way because it's by far the easiest and it makes sense. So cache control is basically these are called directives in GraphQL. They are kind of half standardized. So you can basically set the max age on things. You can set it on top level type, you can set it on each field any way you want it to. To have a different time on the read count basically only makes sense if you are getting it from somewhere else. Like if you get the post, you get the post data, but then you have another table that has stats for the posts, and then you go and get it from that. If this was all data that was coming from the same table, it wouldn't make sense to have different max ages. And this is the standard that Apollo came up with. It's basically from this secret internal info argument that we get in each resolvers, they tack on this cache control. And they have hints. So it's an array with a path. And post here means it's like the top level post. And well, you can guess. So this is the read count field in a post. And there we have the author. I think I will keep my time. So the last thing we're going to do before I say thank you and open it up to questions is we're going to write a resolver that uses data loader and applies the caching logic. But before we show that, we're actually going to show how we use it. So this is kind of the finished example. We have the query, and you can get posts and you can get authors. And this doesn't need much. It's not cached, like I said. Like anytime we ask for posts, we're going to get the posts that you have access to. But then, when this resolves the author, and you want to see the posts in the author, it's going to use this nice little resolve with loader. And we still have the table name first. I think I forgot to put the empty name there. And then we tell it which fields should I query to get the right author, post. And data loader is going to pass in keys to everything. So it's going to pass in only the ID to the post. And this little curly braces thing means that we're going to have replaced the ID here. And the last argument is what's the field called in the root or in the object. So that's basically for Mäklarsamfundet, this file is like 800 lines long, and it's all a bunch of this. We auto-generate it, we don't write it. So data loader. First we write our little new resolver that we, or the resolve factory that we just used. Then we, for each type, we apply the data loader. And the data loader is a really, really simple batching tool. Like, through the whole resolving a query is gonna, for each query, different resolve functions is gonna be called hundreds of times. And what data loader is, it basically keeps track of all the times it was called. And then when the query is finished, it runs through all of the data that it has clung on to. So what you pass to a data loader is anything that handles an array of keys. And we do a promise that maps over the keys. And build a query. So the where here is the ID, curly braces ID thing that we passed in. We have a where because sometimes we have other hard-coded stuff that we put in there, but there's always an ID. So either we add all of the incoming where clauses to the query, and there's a little fail-safe. If there is no where clause, we just query by ID. And this resolver works much like the other resolver, but it checks a cache. And I mean, it's the simplest cache you can imagine. It has the ID and the entity name, so it just basically holds on to that. And it saves the time from when this was saved. So, which we get from here. We pass in the cache control, and it will figure out, okay, what's the max age? When was this saved in the cache? Is it valid? Yes, it's still valid. If it's valid, we get it from the cache. Otherwise, we pass it to the data loader, which will get it from the database. And that is basically the whole caching implementation. Thank you. Questions? Yes?
Yes. So you're using cache directives in your schema, or where do you utilize them? Do you use the Apollo engine for caching?
No, we use Apollo Server. And Apollo Server, because it's Apollo, has automatic access to these cache control directives. So just because I have added them, they are automatically added to this fourth argument to each resolver, the info one. So if you have added cache control directives, you are going to get that metadata there. And it's just really stupid metadata. You have to parse it yourself, but it's all you need.
So have you tried using Apollo engine for caching? Because as I understand it, they use those directives to cache things in their...
Yes, I've tried it for basically the really simple examples.
Yeah.
And it just works.
Okay.
They have the same for permissions. Like Apollo Engine is like a one-stop shop. You can specify permissions also in a kind of directive form, I think. And it will also just work.
And one more. How much traffic does your service handle, like for peak requests per second?
So the question was, how much traffic do we handle? Do we mean active users at the same time, or do we mean...
I mean, your GraphQL service, is it how many requests per second, or how many requests per... How much traffic in that sense?
Not a lot right now, because we've only implemented it for 2 parts of the app. The others are still hitting the REST endpoints. So we have basically the entrance to the app is GraphQL, and another view is GraphQL, but then we have all the little detail pages are hitting the REST endpoints. But I think maybe peak it's only like 10,000 or something per minute. Yes?
What are the downsides to doing it like caching with GraphQL versus doing it the old REST way?
What are the downsides of caching with GraphQL versus doing it the old REST way? Well, the old REST way is simpler. So one downside is that you add complexity. The basic concept of GraphQL, or the reason I like GraphQL, is that we've been building REST endpoints for over 10 years. We have streamlined the process for what is easiest for the backend developers. A backend developer today can basically just apply a bunch of standard tools, sit back, go to AWS seminars. Yeah, profit. The complexity of an app is, typical app is 90% front end, 91% front end, 9% back end. GraphQL tries to equalize this a bit. I would say they at least move it up to like 70-30, something like that. Because you move the responsibility of connecting data to the backend again. Because what we have been doing with REST is basically, hey, you're building a front end. Just call these 80 endpoints and get the data, and then find a way to consolidate the data that fits what we actually want to do. And I also, because the complexity is there, I spend 90% of my time in the front end. And I don't think that the front end should be doing all the work. I think that we should be moving as much as we can to the back end when it comes to the data part. Like, ideally the front end should just get the data it wants, show the data, have forms to change the data, and then show the data again. Yes?
How do you, when you have a query that asks about like many different layers, like going deep in a very deep query,
yeah.
How do you do the performance there against the database? Like how do you get it performant? Because it's a lot of like joins or I don't know how.
So the question is, how do you get deep queries performant? I would say either you do or you don't. It depends on how you profile. We've been profiling some over a long period of time with a diverse set, and it does save a little on the database compared to how we were doing it before, but it's basically comparative. So what we are doing is, for each resolver that gets called, it does the most stupid thing possible. Like, it takes the ID, makes a query. Takes the ID, makes a query. Only one table, no joins. Which means that if we clear the cache and restart the server, like, the first deep queries might make 900 database calls. But then subsequent visits might make one database call, which is the top level one, which we don't cache. Yes?
What would you say are the best use cases for using GraphQL?
The best use cases for GraphQL is everything. Thank you for setting up that really simple question. Okay, thank you.